How's it going, everybody? This video is about function notation. So function notation is really just sort of the grammar of math. It's one part of the grammar of the language of mathematics. So just like there's grammar rules in, say, in an English language arts class, you need to know when to use a comma and when to use a period. Mathematics has the same thing. So this entire video here is purely about grammar in mathematics. And so the objectives of this video, we'll look at some examples of using function notation. That second bullet point, function notation is just a visual cue. It is just grammar. So it just gives a different way to represent an idea that you already know. And the idea that you already know is how to plug in. So if you know how to plug in, then this is just a different way of representing that. And the last thing, do not confuse function notation with multiplication. That would be like confusing a comma with a period or something in the English language arts example. But anyway, let's jump into it and we'll see what I'm talking about. So first of all, a function. What is a function? Well, remember, functions have inputs and outputs. A function, you can think of it like a little machine that takes something in and gives you something out. You can ask it a question, the input, and it gives you out an answer, the output. So function notation just gives a very visual way to represent this. So mathematicians wanted to have concrete and clear ways to write things down so that when they communicate with one another, it's clear what they mean. And so here's what this looks like. So f, this is red, this part here is read f of x, typically. Some people will say f at x. But these parentheses, what these parentheses are doing here is saying you have a function, and we're going to call that function f. That function f, that's the name of it, it takes as input this variable x. And so the whole point of these parentheses it's really just a visual trick. It makes it look like the x is inside of the f, right? So if you think of that function f as being like the machine, you're going to put something into the machine. In this case, it's an x, and the machine is going to do its machine thing and give you something out, right? And so that's really all there is to it. You'll see this f of x as sort of common variable letters, but other variable letters work too. So let's look at an example. So say that m is a variable representing the amount of money in dollars, and t is a variable representing how many hours you've worked. So then m of t, what is this? This is going to represent the dollars that you've earned after working for t hours, right? So again, the whole point here is that this now looks like the t, the amount of time, goes into this function, and what comes out is m, the amount of money, right? So in this case, we're saying that the amount of money, let's say you have a job, and let's say, like in this model here, it pays $7.50 an hour. So the amount of money you make is a function of how much time you work. The more you work, the more money you will make. And this function notation, all it does is it shows us that the m and the t are related in this way, that the time is the input to how much money you get on your paycheck. So you can now plug in. And again, as long as you already understand what it means to plug in, then this function notation is just a different way of representing that. So for example, if we plug in t equals 1, we're going to represent that. Remember, inside the parentheses is the t, the amount of time. So if you've worked for 1 hour, you now plug the 1 in for the t into this model, $7.50 times t. Well, if that t becomes a 1, then you do 7.5 times 1, which is $7.50. If you've worked for 2 hours, now look at the 2 is inside of the m, then you get 7.5 times 2. Everywhere you see a t, it now becomes a 2. And same thing with t equals 3. M of 3, again, the amount of money you've earned after working 3 hours. So again, this is purely a visual notation. You're not learning any new math here. All you're learning is a way to write this down concretely. That's a common way you'll see in textbooks and other math writing, right? Let's do another example. Let's say instead of an algebraic representation of a function, I have two variables a and g, and I capture the data in a data table. So you have a on the left and g on the right, and they get paired up. So when a is 0, g is 12. When a is 200, g is 34. When a is 23, g is 93. And when a is 12, g is 94. So one way you could write this one data point, this row here, is the example I picked out. When a is 23, g is 93, you can write g of 23 equals 93. And again, now this here gives me a visualization of how g depends on a. G depends on what goes inside. G is like the function machine, and it depends, what comes out of it depends on what you put in. So if you put in 23 to g, the function g, you get out 93. Right? So this would be g equals 93. You could just write g equals 93, but that's less specific than saying when a is 23, g is 93, and that's where this notation comes in handy. It's showing me very clearly that when a is 23, g takes in that a and gives you out 93. Okay. Last is a warning. Function notation uses parentheses. Multiplication also uses parentheses. Do not confuse these two. Again, that would be like confusing your rules of grammar and writing sentences that don't make sense. So how do you know when to use each? Just read within context. Okay? So let's look at just a couple examples here. So in blue, I have parentheses, but this is clearly not a function, right? Because everything is a number. I have a 6 times a parentheses 5 plus 3, and then that does equal 6 times 5 plus 6 times 3 using the distributive property, right? But clearly these parentheses are not indicating a function, right? On the other hand, let's say I have f of, and then I put a bunch of stuff in the parentheses, an x plus a 1. Okay, whatever, you can put whatever you want inside the parentheses. Say I put an x plus a 1. This is not saying do f of x plus f of 1, right? Because this is not multiplication. Okay, so you have to read within context. So this is something different, and we'll actually look at some examples with this particular form here. But I just wanted to point out that, you know, when you see parentheses for multiplication, you'll be pretty sure it's multiplication because of how it's written, right? It'll be clear that you're supposed to be multiplying things. But if there's a function involved, something like an f of x, then these parentheses no longer mean multiplication, and you just have to read within context. Okay? So you can't multiply this thing out like you could with the numbers. So that's all I got. Thanks for listening, and have a good one.